All right, in this problem, I think we did this one in class, but in this problem we have the wall, we have a beam that's going out like this, we have a cable attached to it that's at an angle of 30 degrees, right? And there's a mass on this, and then there's the the weight of the beam and the weight of the mass. Weight of the beam is 300 newtons. The wire can withstand a maximum tension of 500 newtons. And so the question is, what is the maximum distance x for the wire breaks? Bar is 3 meters, weight 300 newtons. Okay, 3 meters, 500 newtons. And I'm missing, oh, weight of the box. Oh, I'm missing a sentence in this one. Give me just a second. 3 meters and its weight is 200 newtons. Also, let the block's weight, W, equal 300 newtons. Okay, now we have all the information we need. Apparently I didn't type everything. Okay, so we got a 200 newton bar, we got a 300 newton box. The angle the wire makes is 30 degrees, and so the question is, and the wire breaks at 500 newtons, what is the maximum possible distance x before the wire breaks? Okay, so 3 meters, right? X is the distance out to the box. The weight of the beam itself is going to be at the 1.5 meter mark. Since it's a uniform beam, this is at 30 degrees, so the vertical component of this is the tension times the sine, right, of 30 degrees. And it's that because this is the component of the vector opposite to the angle, right? And then the horizontal component is going to be tension times the cosine, or minus the tension times the cosine, because it's headed off in the negative x direction. There's going to be a force horizontal from the wall, and there's going to be a force vertical from the wall. So we have our horizontal forces, our vertical forces. Our vertical forces cause torque, right? Our vertical forces cause torque, and so we apply the statics equations. All right, let's start with the sum of the forces is 0. All right, so let's look at in x, or in y. So there's the vertical force at the there we go, at the beam, minus the 300 newtons for the box, minus the 200 newtons for the beam, plus the tension times the sine of 30 degrees. All right, and that gives us our equation in the vertical direction, and then in the horizontal direction we have the horizontal force minus the tension times the cosine of 30 degrees. Since there are no horizontal forces exerted by either the weight of the box or the weight of the beam, our only horizontal forces are the force the wall is exerting, FH, and the tension times the cosine of that angle. And finally, some of the torques must be 0. Okay, so the torques due to the box is 300 newtons times x. The torque, and that is a negative torque since it would be clockwise. The torque due to the weight of the beam is 200 newtons times 1.5 meters, right? And the torque due to the, no, okay. This is the torque about the point where it attaches at the wall. So the distance for FV is 0, and so it drops out of this equation, right? 0 equals all of this, and the last term is the torque due to the what am I thinking? Torque due to the beam, due to the wire. All right, and that is times the whole 3 meters. Now, fortunately, out of this, the only thing that's left is the tension. Right, it's our only unknown. So the tension is 200 newtons, 300 newtons plus 200 newtons times 1.5 meters. 200 times x. Sorry. Tension is this. And let me back up. I'm backing up. I'm backing up because what is the maximum possible distance for the wire breaks if the wire breaks when the tension is at 500 newtons. So what we really want to do here is we want to set the tension equal to 500 newtons, and then solve for x when the tension equals 500 newtons. All right? Okay. And so that gives us 500 newtons, okay, is 0 is minus 300 newtons times x minus 200 newtons times 1.5 meters plus the 500 newtons times sine of 30 degrees times 3 meters. Okay, so take the x over there, divide by 300. So we have 500 newtons, which is the tension, times the sine of 30 degrees, times 3 meters, right, minus 200 times 1.5 meters, what did I, oh, times 3 meters. Yes, you don't put units in Excel. Okay, and now we need to take that and divide it by the 300 newtons, and so we get 1.5 meters. So once we exceed 1.5 meters, the tension hits 500 newtons and the wire breaks. All right, that's part A. Part B. Part B is the horizontal force is just the 500 newtons times cosine of 30 degrees, right? It's 500 times cosine of 30, 433 newtons. And then part C, the vertical component, is going to be 500 newtons minus 500 newtons minus 500 times sine of 30 degrees. It's 250. All right, that makes sense. 500 newtons minus that. Okay, and that's it for problem 28.